Hello student, welcome to my channel The Learn Physics. Today I will be discussing the current electricity of class 10. When a potential difference is applied across a conductor, the free electron moves in the conductor. This movement of free electron produces current. Now what is current? Current is the rate of flow of charge per unit time. If capital Q be the charge flow in time t, then current I equal to this is the Q by T. The unit of charge is Coulomb and unit of time is second. So unit of current becomes ampere. So look at this, ampere equal to this is the Coulomb per second. Okay. Look at this, a current of 0.5 ampere flow through a bulb for 10 minutes. We have to calculate the amount of charge flow through this. Look at this, here I is given, time t is given. We have to calculate Q. Now what is the relation of Q with I and T? Now look at this, we know current I equal to this is the Q by T. So Q equal to current I into T. So look at this, I equal to 0.5 and this is the 600. So this is the 300 Coulomb. Okay, understood? Now next. Now look at this, another numerical. How many electrons remain in 1 Coulomb charges? So look at this, here Q equal to 1 Coulomb, magnitude of charge of electron 1.6 into 10 to the power minus 19 Coulomb. We have to calculate the number of electron. So look at this, the number of electron, this is the Q by E, this is the 1 and this is the 1.6 into 10 to the power minus 9. So look at this, this is the 6.25 into 10 to the power 18. Okay, so number of electron in 1 Coulomb charge is equal to 6.25 into 10 to the power 18. Understood? The path of flow current is called electric circuit. It consists of an electrical source, that is a cell or battery, a resistance, look at this, a resistance, capital R. It may be a bulb, maybe a heater, or maybe a electric fan or any other electrical equipment. Okay, and next, an ammeter which measures the current. Okay, and finally this is a switch K. Now look at the symbol of the component of an electrical circuit. First of all, electrical cell. Cell is represented by this way. This is the positive terminal and this is the negative terminal. Battery. Battery is the combination of cells. So battery can be represented as, look at this. This is the positive, negative, again positive, negative, again positive, negative. Okay. Now plug key. Plug key can be represented as, look at this way. This is the open and this is the closed. Okay. This is the plug key. This is the open and this is the closed. Okay. Understood? This is an electrical bulb. Okay, bulb can be represented this way. Okay, next. Now look at this, this is the resistance. Okay, this is the resistance. Now look at this, this is the variable resistance. This is the variable resistance. And look at this, this is the ammeter plus minus. And this is the voltmeter. This is the plus, this is the minus. Okay, so look at this, this is the cell, this is the battery, this is the plug key open, plug key closed, bulb, resistance, variable resistance, ammeter and voltmeter. Understood? Next. Now electric potential. Electric potential is the amount of work done to bring an isolated unit positive charge from infinity to a point in the electric field. Suppose look at this, we have to calculate the potential at the point P. So potential at the point P is the amount of work done to bring an isolated unit positive charge from infinity to this point is called electrical potential. It is a scalar quantity and it does not depend on path. It depends on initial position to final position, and it is a state function, not the path function. Okay, its SI unit is volt or joule per coulomb. Okay, now potential difference. Potential difference is amount of work done to bring an unit positive charge from one point to another point is called potential difference. Look at this. Suppose this is the, look at this, suppose this point P and this is the Q. Now the amount of work done to bring a unit positive charge from Q to P is the potential difference between P and Q. So look at this, the potential difference between P and Q, V equal to work done divided by charge. We know the unit of work done is joule, unit of charge is coulomb. So unit of potential difference is, this is the joule per coulomb or volt. Understood? Or volt or simple capital V. Okay? Therefore, W equal to V into Q is the required relation of electrical energy, which is the product of potential difference and amount of charge flow between the 2 points. Okay? Understood? Now next. Now definition of volt. If amount of work done to bring 1 coulomb charge from one point to another point is 1 joule, then the potential difference between the 2 points is 1 volt. Therefore 1 volt equal to 1 joule divided by 1 coulomb. Okay? Understood? Now a numerical. Find amount of work done or energy required to move 2 coulomb charge from one point to another point having potential difference 12 volt. Now we know, look at this, V equal to work done by charge. Now look at this, so work done is equal to V into Q. Now look at this, here V equal to 12 volt, Q equal to 2 coulomb. Therefore this is the 12 into 2, so this is the 24 joule. Okay? Understood? Next. Now a question. Which device helps to maintain a constant potential difference in a circuit? Look at this, a cell or a battery maintains the constant potential difference in a circuit. Next question, what is the amount of work done to bring 1 coulomb charge from one point to another point having potential difference is 1 volt? So look at this, we know the work done is equal to, this is the Q into V, Q equal to 1 coulomb, V equal to 1 volt, so work done becomes 1 into 1, so this is the 1 joule. Understood? Now next numerical. Find amount of energy needed to bring 1 coulomb charge from one point to another point having potential difference 6 volt. So you know W equal to, this is the Q into V. What is the Q? Q is the 1 coulomb. What is the V? 6 volt. So look at this, this is the 1 into 6, so this is the 6 joule. Okay? Understood? Now next. Now Ohm's law. If material, temperature And physical condition. Physical condition means length, breadth, etc. Remain constant. Then amount of current flow through a conductor is directly proportional to potential difference across it. If V be the potential difference due to current flow I, then V proportionate I. Therefore, look at this, from this relation V equal to Ri, where R is constant, which is the ratio between voltage and current, is called resistance of this conductor. So according to Ohm's law, resistance is the ratio between potential difference across the conductor and current flow through this. In SI system, the unit of potential difference is volt, unit of current is ampere, then unit of resistance becomes ohm. Look at this is the ohm. Okay, so look at this, ohm equal to volt by ampere. This is the required relation between resistance, potential difference and current flow. Okay, now the definition of ohm. If 1 ampere current flow through a conductor produces a potential difference of 1 volt across it, then resistance of the conductor is 1 ohm. Now I may repeat, if 1 ampere current flow through a conductor produces potential difference of 1 volt across it, then resistance of this conductor is 1 ohm. So look at this is the V equal to IR, is the relation of current, voltage and resistance. Now Ohmic conductor. The conductor in which Ohm's law is obeyed is called Ohmic conductor. For Ohmic conductor, the VI graph is straight line passing through origin. Okay, all metals are Ohmic conductor. Then non-Ohmic conductor. The conductors in which Ohm's law is not obeyed is called non-Ohmic conductor. Semiconductor, transistor, etc. are the non-Ohmic conductor. Okay, next. Look at this. What amount of current draw a bulb of resistance 1200 volt from a source of 220 volt? From a source of potential difference 220 volt. Now look at this, here V equal to 220 volt is given. Resistance of the bulb is also given. Now we have to calculate the current. From Ohm's law we know V equal to I into R. So look at this. IR, this equal to V. So I equal to, this is the V by R. Okay. Now here V equal to, this is the 2 to 0 and R equals to, this is the 1 to 0 0. This is the ampere. Now this and this cancel out. Look at this. This is the 11 and this is the 60. So this is the 11 by 60 ampere current drawn by the bulb. Okay. Now next numerical. What amount of current draws by a heater of resistance 100 ohm from a source of potential difference 220 volt? Now look at this. From Ohm's law, V equal to IR. So from this relation, I becomes, this is the V by R. Now look at this. Here V equal to 220 volt. Look at this. This is the 220 volt. R equals to 100. Look at this. This and this cancel out. So this is the 2.2 ampere is current drawn by the heater from the source of PD to 20 volt. Understood? Now next. Now look at this. When potential difference across a heater is 60 volt, the heater draws a current 4 ampere. What will be the current flow through the heater if potential difference across the heater is 120 volt? Now from this condition we have to calculate the resistance R of the heater. Now we know according to Ohm's law, resistance R equal to V1 by I1. Look at this, here V1 equal to 60, I1 equal to 4. So look at this, this is the 60 by 4. So this is the 15, so this is the 15 ohm. Okay, volt by ampere, this equal to ohm. Understood? Now next, here potential difference given, resistance is known, I2 can be obtained. Now from Ohm's law, I2 equal to, this is the V2 by R. Now V2 equal to 120 volt and R is the 15 ohm. So this is the 8 ampere. Okay, understood? Next. Now resistance. Resistance is the obstruction offered by a conductor when current flow through it. It depends on material. Number 2, length. Number 3, area of cross section. And number 4, temperature. First of all, material. Different material have different resistance. Silver has least resistance. Next, length. Look at this. If material, area of cross section and temperature remain constant, then resistance R is directly proportional to length of it. Therefore, length increases, resistance also increases. Length decreases, resistance also decreases. Next, area of cross section. Look at this. If material, length and temperature remain constant, then resistance is inversely proportional to area of cross section of the conductor, that is R proportionate 1 by A. That is, if area of cross section decreases, then resistance increases, that is obstruction increases. Therefore, in thicker conductor, the current flow easily than the thinner conductor. Okay? Now, temperature. The resistance of metallic conductor increases with increase of temperature and decreases with decrease of temperature. And for non-conductor, resistance decreases with rise of temperature. Okay? Now resistivity. Look at this. Now combining two relations, we get R equal to rho L by A. Look at this. This is the rho. Rho means RHO, rho. So R equals to rho L by A, where rho is constant, called resistivity of the conductor. Now look at this. If L equal to 1, A equal to 1, then look at this. If L equal to 1, A equal to 1, we get rho equal to R. Rho equal to R. Therefore, the resistivity of a conductor is the resistance between two opposite faces of a unit cube. Its unit is ohm meter. Okay. The resistivity of a substance depends on material and temperature. It does not depend on physical condition, that is length and area of cross section, but resistance depends on material, temperature, length, area of cross section. Okay, look at this. Alloy has more resistivity than the pure metal, and alloy does not oxidize at high temperature. That is why the heating coil of toaster heater are manufactured with the help of alloy. Okay, understood? Now resistance due to stretching. Look at this. Suppose a conductor of length L and area of cross section A. Okay, so its resistance R becomes rho L by A. Now this wire is stretched in such a way that its length becomes twice. If length becomes twice, its area of cross section becomes half. Now look at this. Look at this. This is the, look at this. This area of cross section becomes A by 2 and length becomes 2L. So look at this. What is the resistance? Look at this. R equals to rho into twice L divided by A by 2. Look at this. This 2 and this 2. This is the 4. Rho L by A. So this is the 4R. Look at this. So resistance becomes 4 times of this resistance. So this is the 2 square R. So if a wire is stretched 2 times, its resistance becomes 2 square times, that is 4 times. If a wire is stretched 3 times, its resistance becomes 3 square times, that is 9 times. Understood? Next. Now look at this. The resistance of a wire is 26 ohm and length 1 meter. The diameter of the wire is 0.3 millimeter. So radius becomes this. We have to calculate the resistivity. Now look at this. Here R equals to rho L by A. Look at this. So rho becomes R A by L. Now R into, this is the pi R square divided by L. This is the 26 and this is the 3.14 into 0.3 by 2 into 10 to the power minus 3 whole square divided by 1. Okay. Now look at this. This is the 26 into 3.14 and this is the 9 by 4 into 10 to the power minus 8. This is the ohm meter. And we get this is the 1.84 and this is the 10 to the power minus 6 ohm meter. This is the resistivity of manganese. Okay, next. Now look at this. A copper wire of diameter 5 into 10 to the power minus 4 meter. Resistivity 1.6 into 10 to the power minus 8 ohm meter. And resistance 10 ohm. We have to calculate length of the wire. Now second question. If the diameter becomes double, what is the resistance? Look at this. If diameter becomes double, then area of cross section becomes 4 times. If area of cross section becomes 4 times, then resistance becomes 1/4 time. That is, resistance becomes 10 by 4. That is 2.5 ohm. Okay, understood? Diameter double, area of cross section 4 times. Area of cross section 4 times. That is, resistance becomes 1/4 times. Okay. Now look at this. We know here R equals to rho L by A. Look at this here. So L equal to, this is the RA divided by R. So look at this. L equals to RA divided by rho. Now here R equals to 10 ohm. a equals to pi d square by 4 and rho equals to, this is the 1.6 in 10 to the power minus 8. Look at this, 10 into pi 3.14. Now d is the 25 into 10 to the power minus 8 divided by 4 into 1.6 into 10 to the power minus 8. This and this cancel out. Okay. Now next, look at this. Look at this 25 and this is the 31.4. So this is the 31.4 into 25 divided by 4 into, look at this, here 4 into, look at this, here 4 into 1.6. So this is the 6.4. So here 314 into 25 divided by 64. This is the meter. Okay. This is 122.65 meter. Okay. Many thanks for watching this video. This video will be extremely helpful for your preparation in board examination. Please like, share and comment on this. And if you are new, don't forget to subscribe my channel to get the new videos of this type. Okay.